Picture a chess position with no piece captured yet, no reward on the board at all. And yet a grandmaster glances at it and simply knows it's winning. How? They're estimating something the board doesn't show directly, the long-term promise of that situation. That is exactly what a value function does for a reinforcement learning agent. It looks at a state and estimates how much total future reward is coming. It's the compass at the very heart of reinforcement learning, and once you truly grasp it, half the field suddenly clicks into place. Let's break it down. Look, at its core, a value function does one simple job. It takes a state, imagines the whole future that follows from it, and boils all of that down into a single number. Follow the steps one at a time. Start with a single state, the agent's current situation. Maybe a board position, a spot in a maze, a configuration of a robot. On its own, it might carry no reward yet, but it's the starting point for everything that comes next. Now imagine following your policy from here, step after step, collecting rewards along the way. The value function adds up all of that future reward, the entire stream you expect to earn from this state onward. That running total is the raw idea of value. But rewards far in the future matter a little less than rewards right now, so each one is discounted, shrunk depending on how many steps away it sits. This keeps the total finite and reflects a sensible preference for payoffs that come sooner. Finally, that discounted expected total gets stored as the value of the state. One number saying how promising this situation really is. Do that for every state, and the agent suddenly holds a map of which situations lead somewhere good. So why does this one number matter so much? Here's the contrast laid side by side. Chase only the immediate reward and the agent becomes short-sighted. It grabs whatever looks good this instant, blind to the fact that a small reward now might lead straight into a dead end, while a patient move sets up something far bigger later. Greedy on the moment is often terrible in the long run. A value function fixes this by folding the entire future into every decision. It captures the expected long-term reward from a state, so a move with no immediate payoff can still be recognized as brilliant, purely because of where it leads. That forward-looking view is what separates real strategy from mere reflex. Strip everything away and three ideas make the value function essential. It estimates expected future reward, not just the reward sitting in front of you. There are two flavors. V of S scores how good a state is under your policy, while Q of S, scores taking a specific action first, then following the policy. That Q is exactly what Q-learning learns. It's defined recursively through the Bellman equation. The value of a state equals the immediate reward plus the discounted value of wherever you land next. That self-referential structure is beautiful because it lets the agent learn values by bootstrapping, improving each estimate from its neighbors. It turns long-term planning into simple greedy choices. Once you can estimate value, picking an action is easy. Just move toward the highest value within reach. That's why value functions underpin Q-learning and DQN and act as the critic inside actor-critic methods. Alright, let's lock in what matters. A value function estimates how much total future reward an agent can expect, turning a distant goal into a single number it can actually optimize. Comes in two forms, V of S for the value of a state, and Q of S, for the value of taking a specific action first. Values are defined recursively by the Bellman equation, and in huge spaces we approximate them with a neural network, which is precisely what deep reinforcement learning does. Because value looks forward, choosing actions collapses into picking the highest value nearby, turning hard long horizon planning into easy local decisions. If reinforcement learning explained this cleanly is your thing, a whole library of it is waiting at standarity.com. Come learn with us.